Okay, so this is 7th grade lesson 3.5, and we're going to go over two-step equations. And our goal is I can solve two-step equations using inverse operations. Now, the process for two-step equations, it's the same thing as one step, only now there are two steps. So what you do is you undo problems in the reverse of how you would have solved it if you knew what the variable equaled. So for example, if you knew ahead of time that x equaled 2, you would follow your normal order of operations. You would multiply, and then you would add or subtract. In this case, we're going to undo it. We're going to go in reverse order. So, you take your order of operations, and you basically go backwards. Now, we're going to go through, we'll practice this, we'll spend a lot of time on this just to make sure that you know exactly what you're doing. So here we've got our examples. Now let's just focus on the first one. Ignore all these others. We'll get to them later. Okay? There we go. So we've got 14 minus 2x is equal to 30. Now again, if we knew what x equaled, then I would just plug in, I would multiply first, and then I would do the 14 minus whatever 2 times x is. So the first thing I need to get rid of is the 14. Okay? A way that I've taught classes before is if you think about this as a football game and there's a giant pile-up. When the ball goes loose, all of the players jump on top of it. And it's literally all of the players, including that one really big guy that can't run very fast. And he just basically, it's like he does a belly flop onto a pile of human beings just because it's fun. I don't know. I don't understand why, but that's what happens in football. So anyway, this is like the ball is loose, all of the football players have jumped on it. What the referees do is they start by taking the people from the top that are furthest away from the football. In this case, the x is the football. So I'm going to take the number that's the farthest away from it, or the least connected to it. So if we look at this, the x is being multiplied by 2. This 14, the 2x is being subtracted from it, but it's really not that connected to the x, but it's still on the same side as the variable. So that's the first thing I want to get rid of. Now this is a positive 14. The way to get rid of a positive 14 is to subtract 14. So I'm subtract 14 from both sides. Because this is an equation, it has to stay balanced or equal. So what you do to one side, you have to do to the other. Now, whenever I do 14 minus 2x and then I subtract 14 from it, the 14 can only come away from the other 14 because that's the minus 2x and minus 14, those are not like terms, so I can't combine them. So I take 14 minus 14 is 0. So I'm left with negative 2x, and please note, this minus 2x, remember, becomes a negative 2x, so that's how we read it. On the other side, 30 minus 14 is equal to 16. And again, you notice I drew a line to separate the two sides just because that works best for me. Now this is negative 2 times x. To get rid of that, I'm going to divide by negative 2 because the opposite of multiplication is division. And I want to do that to both sides. So negative 2x divided by negative 2 leaves me with just x. 16 divided by negative 2 gives me negative 8. Now if I want to go back and check that, if I multiply this 2 times negative 8, that gives me negative 16. 14 minus negative 16 is equal to positive 30. So I know I've done this correctly. So you can always go back and check your answer. There's no reason to ever miss one of these problems. So let's look at the next one. We have x divided by 3 plus 4 is equal to 9. So again, I want to go in reverse order of operations. Normally I would divide first and then add, so I'm going to get rid of the addition first. If you think about it, the x is being immediately divided by the 3. That plus 4 is just being added on after the fact. So that's the first thing I get rid of. Now I get rid of plus 4 by subtracting 4. So I subtract 4 from both sides. Now that leaves me with x divided by 3 on the left-hand side. On the right-hand side, 9 minus 4 is equal to 5. So x divided by 3 equals 5. Now we undo division by multiplying. So I'm going to multiply both sides by 3. X divided by 3 times 3 gives me with just x. 5 times 3 is 15. So x equals 15. And again, go back and check. 15 divided by 3 plus 4. 15 divided by 3 is 5. 5 plus 4 is 9. I've done this correctly. 2 more examples. So here it's written kind of backwards. So we've got 15 is equal to 3x minus 6. If you want to rewrite it as 3x minus 6 equals 15, that is totally okay. So looking at it, normally I would multiply first and then subtract. So I'm going to add. Also, the x is being multiplied by the 3, the minus 6 again. It's just kind of an afterthought. So I add 6. And I do that to both sides to keep it equal. Now 15 plus 6, is 21. Over on the right-hand side, negative 6 and plus 6 cancel out, just leaving 3x. So 21 is equal to 3 times x. Well, the opposite of multiplication is division. So I divide both sides by 3, and that gives me 7. 7 is equal to x. And go back and check. 3 times 7 is 21. 21 minus 6 is 15. I've done this correctly. Last one. Now this one is a little bit different. So we've got y minus 2 in parentheses divided by 5 is equal to negative 4. Now in this case, I would actually subtract 2 first. If I knew what y equaled, I would first subtract 2 and then divide it by 5. And you notice that 5, again, is the farthest away from x, or from my variable. It's the last thing I deal with. So what I'm going to do is get rid of the division first, because I would solve the parentheses and then divide. So I undo division by multiplying. Multiply both sides by 5. This gives me y minus 2, and I took it out of the parentheses because there's nothing else there, so I can take it out, is equal to negative 20. Now to get rid of minus 2, I add 2. This gives me y is equal to negative 18. And if I check this, negative 18 minus 2 is negative 20. Negative 20 divided by 5 is negative 4. So I've solved it correctly. Now we'll spend a couple days on this. So you definitely know how to do this. We're going to spend a lot of extra time. We're going to look at some problems where we actually set it out with manipulatives. You're going to see how this works. So we're going to do a lot of practice. Come with any questions tomorrow.